Good afternoon. My name is Gabriel Bermudez, and I'll be going over quiz number 4. Now, the purpose of this quiz is that we want to determine the differential equation and its solutions that correspond to resonance, but for a Cauchy equation. To obtain it, we need to follow these steps. So step number 1 is that we want to create a function that has a forced harmonic oscillator subject to resonance and give its general solution. The equation I chose was one that we went over in lecture. y y double or y to the second derivative plus 4y equals to sine of 2t. From the lecture, we gathered that the y homogeneous is c1 cosine of 2t plus c2 sine of 2t, and that the y particular is negative t over 4 sine of 2t. If you just move these two together, we get our general solution, which is c1 cosine of 2t plus c2 sine of 2t minus 1/4 t times sine of 2t. The second step is that we want to use a change of variables x of e to the t or x equals e to the t to rewrite your equation as a Cauchy equation. You can use it then mentions that we can use some results that we got from 19.2. So what we're going to do is that from 19.2, we gather that d over dx equals to e to the negative t times d over dt. We can change this to dy over dx and dy over dt, and simply move the et over to the other side and get dy over dt equals e to the t dy dx. Similarly, we get from 19.2 that the second derivative of y with respect to x is equal to this thing. What we can do is simply move the e to the 2t over to the left side and get the second derivative of y with respect to t minus the first derivative of y with respect to t equals to e to the 2t times the second derivative of y over or with respect to x. Now, since we do not have the first derivative of y with respect to t in our original equation, what we can do is simply subtract 1 from it and then add 1 to it. As minus the derivative plus the derivative of y would just equal 0. It doesn't change the equation at all. So we get our original equation, we subtract the first derivative of y and add the first derivative of y to it. And then what we can do is we simply grab what this equals to and what this equals to here and plug it into this equation right here and get this long line. And with our change of variables and what t equals to, and a little change of it to make t the front runner here, we just to get this, we just simply take the natural log of both sides. We get this final equation, x squared equals the second derivative of y with respect to x, plus x with the first derivative of y with respect to x, plus 4y equals to sine of the sine of 2 times the natural log of x. And lastly, the last step is to write the solution corresponding to the equation we obtained. What I did was that I grabbed the general solution that we got in part 1, and since we're just applying a change of variables to even get to here, I apply the same change of variables to this one, replacing all the t's with ln of x to get the general solution for y equals to c1 cosine of 2 ln of x plus c2 sine of 2 ln of x minus 1/4 natural log of x times sine of 2 natural log of x. Thank you for listening.